So here one question is given which goes like this. Derive the expression for the energy of a particle in a one-dimensional box and discuss its main consequences. So the particle can be an electron, which is a microparticle, and it is moving in one-dimensional box only, means out of the three dimensions x, y, and z, it is allowed to move along the x-axis only. So let us consider a particle. Here it is solution given here. Let us consider a particle which is electron of mass m, which is confined to move a distance a along x-axis in a one-dimensional box. The particle travels only along x-axis and is confined between x is equal to 0 and x is equal to a by two infinitely hard walls, so that the particle has no chance of penetrating them. So the potential energy V of the particle is infinitely high on the side 1 and side 3 of the box, while when the particle is inside of region 2, throughout the length A, V is uniform. It is assumed that V is 0 inside the box. The potential outside of the box is infinitely high and psi must be 0 in the regions 1 and 3. So we can draw a diagram to show the conditions more clearly. There are the three regions, region 1, region 2, and region 3. And it is here x is equal to 0, and here it is x is equal to a. Now, potential is infinite in the region 3, and potential is also infinite in region 1. Potential exists only in region 2, in which the electron is present, and it can move from x is equal to 0 to x is equal to a. Now, we can write the wave function for the region 2 in the form psi psi by dx square eight pi square me by h square psi is equal to 0. This is the Schrodinger equation in one dimension only, because the particle is confined to move along the x-axis only. So to solve this equation, this is the wave equation for the Schrodinger equation for the particle. Now, what we can say that we will put the value 8 pi square me by h square, that to be equal to alpha square. This is we have taken for solving the equation, this assumption, because then the solution will be easy, because the equation will be converted into a well-known form, that is d2 psi by dx square plus alpha square psi is equal to 0. For this equation, we already know the solution, and the solution is like this: psi is equal to A sine alpha x plus B cos alpha x. This equation solution is of this form, and in which A and B are the arbitrary constants. Now, putting the initial conditions, we can solve in our case uh, as x is equal to 0. When x is equal to 0, wave function is also 0. Why? Because we have assumed here that potential is so high that the wave function cannot exist here at this point. So at x is equal to 0, wave function is 0. So putting these values in above equation, what we see that in place of psi we will put 0, and that will be equal to A sine 0 plus B cos 0. As we know that cos 0 is 1, so B is equal to 0. That is obtained. So in this equation, we can omit this term psi is equal to only A sine alpha x. As B is 0, so this term will not be. This is our equation for the particle in a one-dimensional box. Now for the another condition we have at this point when x is equal to A, also psi is 0 because potential is so high here that it cannot exist. So 0 is equal to A sine A alpha. Okay, then as we know that A cannot be 0 because then the function will not exist. Function is only this much psi A sine alpha. So A is to exist, and then what is the this factor sine alpha x sine A alpha, it is to be equated to 0. And when this is equal to 0, for A alpha to be an integral multiple of pi. When this is equal to n times pi, then sine A alpha becomes equal to 0. So from this, we see that alpha is equal to n pi by a. We have obtained the value of alpha. Now we can write our equation as psi is equal to A sine n pi x by a. So this is the Schrodinger equation, and as we know that here it is alpha is equal to n pi by a. So from here we see that alpha square is equal to n square pi square by a square. Now from this equation, what we had put alpha square is equal to 8 pi square me by h square. So alpha square is equal to n square h square by a square, and that is equal to 8 pi square m by h square. So from this equality, what we get E is equal to n square h square by a square. So this is not pi square. This is This is n square pi square. So n square pi square by a square. So square pi square by a square. E is equal to n square pi square by a square into h square by 8 pi square m. Here pi square and pi square cancel out and we get that E is equal to n square h square by 8 m a square. This is the equation which we get for the energy. Now, in question, it was asked that what are the consequences also. We have to show consequences. So, here are the consequences that free electron can have energy, but when it is confined within a certain range of space, the energy levels become quantized. Here you can see that E is equal to n square h square by 8 m square. Put n is equal to 1, you will get the first energy value. Then put n is equal to 2, you will get 4 h square by 8 m square. So these are all the integral multiples of h square by 8 m square, all the energy values. So energy is quantized. The difference between the consecutive energy levels is not constant. It's another consequence. How? Because when you see the energy difference between the second level and the first level, that is the difference is not equal to the energy difference between the third level and the second level. You can see yourself. So the difference between the consecutive energy levels is not constant. I can show here that E1 is equal to h square by 8 m square. E2 is equal to 4 h square by 8 m square. E3 is equal to 9x square by 8 m square. Now E2 minus E1 is equal to how much? 3h square by 8m square. What is E3 minus E2? That is equal to 5h square by 8m square. So the differences between the consecutive energy levels is not constant. It is not the same. So minimum energy is given by E is equal to h square by 8m square. This is for minimum energy for n is equal to 1. This is equal to h square by 8m square. This is called the 0 point energy. Now, to find out the complete wave equation, what we will do, we will apply the conditions of normalization. Because we have obtained the value of alpha, I can write the wave function as alpha psi is equal to a sine alpha x, and that is equal to a sine n pi by a into x. Now psi square is how much? So a square sine square n pi by a into x. From the normalization condition, we know that integral minus infinity to plus infinity psi square dx, that is equal to 1. As the function is normalized, so we are putting the value of psi square in, and the limits are to be from 0 to a, because x is ranging within these two limits. We will correct the these limits from 0 to a, because in this limit only the function psi is existing. 0 to a psi square dx. And for psi, I will write sine square. A square will come out from this side. A square sine square and pi x by a into dx. That is equal to 1. Now, to integrate it, we'll have to put the value of sine square and pi x by a as 1 minus cos 2n pi x by a divided by 2. That is dx. That is equal to. When we will integrate it, comes out to be equal to 1 by 2 integral dx minus 1 by 2 integral the limit 0 to a 1 minus cos 2n pi x by a. That is equal to 1. I am solving it. We'll get that a square by 2 into a. And here, so this is not 1. This is somewhere here. Only cos minus cos 1 pi x by yes 1 by 2 outside and cos 2 and pi x by a. We have already taken 1 into account here. 1 into dx is integral dx here. So this value, if you see the integral of this thing, it will come out to be cos 2 and pi x will come out to be equal to sine 2 and pi x by a into 2 n pi within the limits 0 to a. Now 2 n pi a that will be equal to 0. Any integral multiple of n pi of sine of that is 0. And at sine 0 is also 0. So this term will completely disappear. This will vanish. And what will obtain? This whole thing is equal to 1. Hence a square into a by 2 that is equal to 1. Or a is equal to double 2 by 2. So from this value, I can write the value of psi. Psi is equal to a sine n pi x by a. So here I can write it equal to under root 2 by a sine n pi x. So it is also one of the consequences of the energy equation for the electron moving in a one-dimensional box that psi comes out to be equal to this much.